In this video, we're going to look at solving simultaneous equations, and the method we're going to use would be substitution. So here I have my question. We have solved the pair of simultaneous equations. We have 4x take away 3y is equal to 1, and we have x plus 3y is equal to 19. Now, the first thing I'll do is label my equations. So the first one, we're going to call that equation 1. And the second one, we call that equation 2. Now, let's notice something about both equation 1 and equation 2. We have two variables, and those variables are x and y. Now, the number in front of the variable is called the coefficient. So the 4 here is in front of the x. Therefore, for equation 1, the coefficient of x is 4. And for equation 1, the coefficient of y is -3. For equation 2, we see nothing in front of the x, but we got to understand x means 1x, so there's a 1 in front here. So the coefficient of x for equation 2 is 1, and the coefficient of y for equation 2 is +3. Now, the easiest thing to do when using the substitution method is look for the equation where the coefficient of a variable is 1, meaning equation 2, the coefficient of x is 1. You don't see the 1, so you can just say, look for the symbol that has nothing in front of it. So we'll choose equation 2 based on that, and we'll transpose for x because x has nothing in front of it. Well, we know it's a 1, but we're not seeing anything. Now, bear in mind, you could choose any equation. We could choose equation 1. We could transpose for x in equation 1. We could transpose for y in equation 1. Same thing, we could transpose for y in equation 2 as well. Now, I'll do that after and show you what happens when you have a number besides 1 in front of your variable. So as I said, we are using equation 2, and we're going to transpose for this x. So using equation 2, we are going to transpose for x. And now transpose for x means, you want x by itself on one side of the equal sign. It doesn't matter if it's on the left-hand side or the right-hand side, as long as the x is by itself. So I'm going to write down equation 2, which is this here. So we have x plus 3y is equal to 19. And if we want this x by itself, it means we have to get rid of this positive 3y that's on the left-hand side of the equal sign. So this is the left-hand side, and this 19 is on the right-hand side of the equal sign. So what I want to do is keep this x on the left-hand side and move this positive 3y across to the right-hand side. Now, when I move this positive 3y across to the right-hand side, the sign in front of it will change from positive to negative. So I just duplicate the above line down here, and I'm going to show the transfer in. So you see I'm taking the positive 3y and I'm transferring it across the equal sign, and as it goes across the equal sign, the positive sign will change from this positive to negative. So now we have this -3y, which we're going to place behind this 19 here. I can just bring the x up like that. And once you have this x by itself like this, you have transposed for x. So now we use equation 2, we transpose for x, and we get this. Now this is looking different from equation 2, but essentially this here and equation 2 is the same thing. This is in a different form because it transpose. So I'm just going to put back here is equation 2. And this new equation, which is the same as equation 2, but because it's looking different, we're going to call that equation 3. So we're going to call this equation 3. Now, this is where the method gets the substitution name from. Because we use equation 2 to form this equation 3, essentially these two are the same, we are going to substitute this equation 3 into equation 1. We cannot substitute equation 3 into equation 2 because we use 2 to form 3. Now, if I'd use equation 1 to form equation 3, then equation 3 would have to go back into 2. But because I use equation 2 to form equation 3 has to go back into 1. So essentially, I'm going to substitute equation 3 into equation 1. So now I'm just going to write out equation 1. So equation 1, we have 4x take away 3y is equal to 1. This is equation 1. And as I said, we are substituting equation 3 into equation 1. Now let's read equation 3. X is equal to 19 take away 3y. Now let's read equation 1. 4 multiplied by x take away 3 multiplied by y is equal to 1. So what I'm going to do is, you see this x here? Because we have x is equal to 19 take away 3y, I'm going to replace this x here with that 19 take away 3y because that's what x is equal to. So I'm going to have 4 multiplied by x, but that x would be 19 take away 3y, close brackets. So you see it? 4 multiplied by x. So now we have 4 multiplied by what x is equal to. And equation 3 shows us what x is equal to. So now we're going to write the remainder of equation 1, which is in negative 3y is equal to 1. So we have negative 3y is equal to 1. Now notice what we have achieved here. We went from having an equation with two variables, being 4x take away 3y, so x and y are your variables, so two different variables, to an equation where we only have one variable. The only variable here is y. And an equation with one variable, we can solve that equation. So I'm just going to write over this line. So we had 4 multiplied by 19 take away 3y, then take away 3y is equal to 1. So now what I have to do here is expand this bracket. So I'll multiply 4 by 19 and 4 by 3y. So 4 multiplied by 19 will give us 76. So I'll have 4 multiplied by 19 is 76. And of course, 4 multiplied by negative 3y, that will give you negative 12y. And then I'm going to write back this negative 3y is equal to 1. Now you can see we have like terms here. We have the negative 12y and the negative 3y. Both of them have negative signs in front of them, so we'll add and keep that negative sign. So 12 plus 3, that will give you 15. So we get negative 15y. So we're going to have 76 take away 15y is equal to 1. Now, when we are trying to find the value of y, it means we want this y by itself on one side of the equal sign. So since the y is already on the left-hand side, I'll keep the y on the left-hand side and I'll move everything else across to the right-hand side. So let's see how we do that. So again, I've duplicated the line. And I'm going to take this positive 76 and I'm going to transfer it across the equal sign. As it crosses the equal sign, it will change from positive 76 to negative 76. And now I'm going to take this negative 76 and put it behind the 1 like this. So we get 1 take away 76. So now we have negative 15y is equal to 1 take away 76, which is negative 75. And now seeing that we have negative 15 multiplied by y, and you want to move this negative 15 across the equal sign, what is going to happen is when you transfer the negative 15 across, the opposite of multiplication, because it's negative 15 multiplied by y. So the opposite of multiplication will take place, which is division. So what we're going to have is negative 75 divided by negative 15. So we have negative 75 divided by negative 15. Now, what I like to tell students is that whenever you are transferring something across the equal sign and you change it from multiplication to division, that number that you're transferring across always goes underneath. It will never go on top. See, the negative 15 went under the negative 75. That will always happen. Now we are dividing two negative numbers, so our answer will be positive. And we know 15 can go into 75 5 times. Or we can work it out like this, negative 75 divided by negative 15. And you see we get positive 5. So we have y is equal to positive 5. Now this is the first part of it, which is the longest part. The next part is going to be short. So we found the value of y. Now remember, our equations have two variables, x and y. So we found the value of y. We still have to find the value of x. Now, when it comes to finding the other variable, so you find y first, the other one is x, right? So when it comes to finding the other variable using the substitution method, always look at equation 3. So you see I found y, but equation 3 has x is equal to 19 take away 3. I see x is equal to. Now, if you had done it in a different way where you found x first, your equation 3 would have been reading y is equal to. So equation 3 will always show the other variable than the one that you found first. Now, if we read equation 3, we have x is equal to 19 take away 3 multiplied by y. So y is equal to 5, so 3 multiplied by 5 is 15, so you're going to have 19 take away 15. But let's write it out and show you working. So what you're going to say is you're going to substitute y is equal to 5 into equation 3. So you're going to write out equation 3, which is x is equal to 19 take away 3y. That's my equation 3. So you're going to put x is equal to 19 take away 3 times y, and y is equal to 5. So we have x is equal to 19 take away 3 times 5, which is 15. So x is equal to 4. Well, 19 take away 15 is 4. So my answers, x is equal to 4, and we have y is equal to 5. Now, let's take the same equation, but instead I'm going to use equation 1 first and transpose for x, and let's see what will happen. What will be the difference? All right, so this time I'm going to say I'm using equation 1, and I'm going to transpose for x. Now, in equation 1, there's a 4 in front of x, so 4 is the coefficient of x. And as I said, anytime you have a number besides 1 in front of a variable, it's going to be a little more difficult. So let's see what will happen. So I'm going to write down equation 1, which is 4x take away 3y is equal to 1. That is equation 1. Then I'm going to transpose for x. So this is the x here. So that means we have to transfer this 4 and this negative 3y across the right-hand side. So I'll leave the x on the left-hand side. So we'll start by transferring the negative 3y across. So by now, we should know that when we transfer this negative 3y across, it will turn to positive 3y. So we'll have 4x is equal to 1. The 1 remains here. And the negative 3y is coming across and will turn positive 3y. So now when we are transfer this 4 across, now remember, we are getting x by itself. The 4 is being multiplied by the x. So whenever we transfer across and the operation is multiplication, the opposite of multiplication will take place when we transfer across, which will be division. And as I told you, once it going across and turn into division, it will always go underneath. All right, so we're going to have x is equal to 1 plus 3y divided by 4. And now this you'll call equation 3. Now, equation 1 looks different from equation 3. But I use equation 1 to form equation 3. So essentially, equation 1 and equation 3 are the same, they're just in a different form. Therefore, I cannot substitute equation 3 back into equation 1 because these two are the same. So equation 3 has to go into the other one, which is equation 2. So I'm going to use the word sub for substitute. So sub equation 3 into equation 2. Now let's write out equation 2. So equation 2 reads, we've seen it up here, x plus 3y is equal to 19. So we have x plus 3y is equal to 19. Now let's look at what equation 3 is equal to. We have x is equal to 1 plus 3y divided by 4. Now notice we have x is equal to, so we have something for x. So this x here, we're going to replace it with the 1 plus 3y over 4 because that is what x is equal to. So where I have the x, I'm going to put 1 plus 3y over 4. That's the x. And the remainder will be the positive 3y is equal to the 19. So I'm going to write the positive 3y is equal to 19. Now notice we went from having two variables, x and y in equation 2. So let's put that in. This was equation 2. All right, so we went from having x and y in equation 2 to only having one variable, just y alone. Now notice this is a fraction. So how do we deal with the fraction? Well, I'll put this 3y over 1 and this 19 over 1 and find the LCM, and that will be the difference here. So whenever we transpose and we end up with a fraction, we're going to have to go and do the LCM. And that is why you want to avoid having a number in front of the variable that you're transposing for. And that's why the first version I did with this, I transposed for this x here in equation 2 because it only had 1 in front of it. So what I should say is, because we had a number higher than 1 in front of the x, we end up with this fraction. And that is something you want to avoid, if possible. So let's go and see how to handle this fraction. So I'll write the 1 plus 3y over the 4 plus the 3y, I'll put that over 1. And I'll put the 19 over 1. And now I'll put this line here because we're going to get the LCM. And the LCM will be between the three denominators. Well, let's have 4, 1, and 1. So the LCM will be 4. That's the lowest number that all your denominators could go into. So you're going to put 4 here. That's my LCM. I'm going to say 4 into 4 is 1. Take that 1 and multiply by the numerator. So it's going to look like this. 1 multiplied by 1 plus 3y. And of course, 1 by anything will give back the same thing. Then we put plus sign. 1 into 4 is 4. So you take that 4 and multiply by 3y, and you get 12y. 4 3s are 12. And then we have 1 into 4 is 4. Take that 4 and multiply by the numerator, which is 19. So we have 4 multiplied by 19, and we get 76. So here we have 76. Now, the beauty of using the LCM on both sides of the equal sign is that after we use it, you see we use it and get this line on top here, we get to drop the LCM. So now I'm going to drop the LCM. So what we're going to have is just the numerator alone. And the only reason we could drop the LCM is because I use this 4 on both sides of the equal sign. I said 4 into 4 is 1, multiplied by the numerator. 1 into 4 is 4, multiplied by the numerator. And see on the next side of the equal sign, 1 into 4 is 4, multiplied by the numerator. So now I get to drop this 4, which is the LCM, and use the numerator only. So I'm just going to write it back. 1 multiplied by 1 plus 3y. Then we have positive 12y is equal to 76. And as I said, 1 multiplied by anything is the same thing, but I'll still do it. 1 by 1 is 1. This is unnecessary. All right. And 1 by 3y is 3y. See, let's get back the same thing. Plus 12y is equal to 76. Again, we have all like terms together here, the 3y and the 12y. So 3 plus 12 is 15. So we have 1 plus 15y is equal to 76. And of course, the positive 3y plus 12y gave you positive 15y. We could transfer this positive 1 across the equal sign out into negative 1. So we have the positive 15y here is equal to 76. Positive 1 goes across to negative 1. So we have 15y is equal to 75. So now we could just transfer this 15 across. The 15 is being multiplied by the y. So when you transfer it across, you're going to turn to division and go under the 75. So we're going to have y is equal to 75 divided by 15. 75 divided by 15 is 5. And here we have our first answer, y is equal to 5. So notice we found the value of y, but what is equation 3 given? X is equal to. So you see, first answer, equation 3 is the next variable, x is equal to. So you can take this answer, y is equal to 5, and put it into equation 3 where this y is, and we'll get the answer for x. So this is 1 plus 3 multiplied by y, so 3 multiplied by 5 is 15. So 1 plus 15 is 16. 16 divided by 4 is 4. And you get x is equal to 4. But let's show the working. So we're going to substitute y is equal to 5 into equation 3. So equation 3 reads x is equal to 1 plus 3y over 4. So we're going to have x is equal to 1 plus 3 times y, and we know y is 5 divided by 4. So we're going to have x is equal to 1 plus 3 5s are 15 over 4. So x is equal to 16 over 4. Well, 1 plus 15 is 16, and 16 divided by 4 is 4. All right, so I don't have space to write answer is equal to, but you can see the answers here. X is equal to 4 and y is equal to 5. Now, in the two versions of working this out, I transpose for x. So I use equation 2 first and I transpose for x. And in the second version, I use equation 1 and I transpose for x. Now, don't think it's only the first variable is transposed for. You can transpose for the second variable, which is y. So what I'll do now, I'll use equation 1 and I'll transpose for the y and show you how that will look. All right, so here I have the question again. And as I said, I'm going to be using equation 1. And I'm going to transpose for y. So I'm going to write out equation 1, which is 4x take away 3y is equal to 1. And now remember, it's this y we're transposing for, so we want this y by itself. So I get rid of this 4x and this negative 3, and it has to go on the other side of the equal sign. So first, I'm going to transfer this positive 4x across the equal sign. I'll turn to negative 4x. Let's put that this is equation 1. All right, so we're going to have the negative 3y here is equal to 1. See, I put back the negative 3y, put back the 1. Now, remember the sign in front of a number is part of the number, so this negative sign has remained in front of the 3. So this positive 4x being transferred across, the sign in front of it changed to negative 4x. Now, when I'm transferring this negative 3 across the equal sign, is negative 3 multiplied by y. So the operation here will be changing to division. So the 3 will remain negative, but what happens is multiplication turned into division. So this negative 3 will go under what's on this side. So we have y is equal to 1 take away 4x divided by negative 3. And now this will be my equation 3. So notice we have fractions again. And equation 3 is the same as equation 1 because I use equation 1 to form equation 3. So I have no choice but to substitute equation 3 into equation 2. So I'm going to write that. I'm going to substitute equation 3 into equation 2. So equation 2 reads x plus 3y is equal to 19. So that'll be x plus 3y is equal to 19. And what we have is y is equal to in equation 3. So that means here I'm replacing the y with what y is equal to, which is the 1 take away 4x divided by negative 3. So I'm going to have x plus 3 multiplied by y. That is what this 3y means, 3 multiplied by y. So 3 multiplied by y, which is equal to 1 take away 4x over negative 3. So I'm going to put that 1 take away 4x divided by negative 3. And then the rest of the equation will be equal to 19. So we have equal to 19. That's going to put that this was equation 2. So again, we have fractions. So I'll put this x over 1. I'll even put this 3 over 1 and the 19 over 1. So we have x over 1 plus, and what we have here is 3 multiplied by this fraction. So I'll write it as 3 over 1 multiplied by 1 take away 4x over negative 3, and I'll put it in brackets like that, is equal to 19 over 1. Now, if you understand that, this here means this, there's no need to write it out like this. You'll understand that this is 3 over 1, and that 3 could cancel with this negative 3 here. As you can see, 3 and 3 could cancel. So I could say 3 into 3 is 1, and 3 into negative 3 is negative 1. So 1 times this 1 take away 4x, so let's give you back 1 take away 4x, and 1 times negative 1 is negative 1. So we'll have x over 1 plus 1 take away 4x over negative 1 is equal to 19 over 1. Now, because we have this negative 1 down here, there's no need for the fractions. We have to understand that this here means 1 divided by negative 1 and negative 4x divided by negative 1 as well. And if we do that, we wouldn't have any fractions anymore because these things over 1 could be written as, this could be written as x again and 19 again. Well, as seen here. So I'll write the x plus, and I'll say 1 divided by negative 1 is negative 1. So I'm going to get negative 1. Negative 4x divided by negative 1 is positive 4x is equal to 19. 19 over 1 is 19. Now, where we have these two signs clashing like that, you multiply two signs, so positive multiplied by negative is just a negative. So we're going to have x take away 1 plus 4x is equal to 19. Now, what we could do is bring like terms together, which is the x here and the positive 4x. So we have x plus 4x. And what I'll do is I'll keep the 19 on this side and bring the negative 1 across the equal sign, transfer it across, and turn positive 1. So we're going to have equal to 19, bring the negative 1 across, turn positive 1. So x plus 4x is 5x, and 19 plus 1 is 20. So now we have 5 multiplied by x. When you transfer the 5 across, change the division. So we have x is equal to 20 divided by 5. And we have x is equal to 20 divided by 5 is 4. So you see, this time we found x is equal to 4. So we found x first. And look at equation 3. Equation 3 is given the other variable, which is y. So what we have to do is go to equation 3 and put in the value for x here. And we'll be able to solve for the value of y. So I'm going to substitute x is equal to 4 into equation 3. And equation 3 reads y is equal to 1 take away 4x, and that means 4 multiplied by x, divided by negative 3. So where the x is, you're going to replace that x with 4. So 4 multiplied by x, that'll be 4 multiplied by 4, which is 16. So we're going to have y is equal to 1 take away 4 times x, and x is equal to 4. So that's 4 times 4, divided by negative 3. So we're going to have y is equal to 1 take away 4 4s are 16, over negative 3. So y is equal to 1 take away 16 is negative 15, divided by negative 3. So now you divide into negatives, so you're going to get a positive, and 15 divided by 3 is 5. So y is equal to positive 5. So our answer, x is equal to 4, y is equal to 5. And that will bring us to the end of this video, and I hope that you'll have a better understanding of simultaneous equations using the substitution method.